All right. Well, good morning, everyone. Welcome to the intro to Dragonfly Cloud presentation. Um, we'll give just a couple more minutes for folks to join, and then we'll kick things off. All right. Well, welcome to the introduction to Dragonfly Cloud. My name is Nick Gottlieb. I'm the VP of Marketing here at Dragonfly. I have Joe joining as well, who is our developer advocate. And the agenda today is to walk through a few slides, just overviewing what Dragonfly Cloud is, some context on why we built it, who we built it for, what are some key use cases, some specific. We'll go through a couple of specific customer use cases, and then we will run through a demo, which Joe's going to lead. So with that, I always like to start by kind of walking through the evolution of in-memory data infrastructure to kind of provide context to how we got to where we are today. So, 25 years or so ago, as web apps were really starting to explode, Facebook was hitting, tens, hundreds of millions of users. We started to experience a problem with scaling that disk-based databases were just too slow and not able to handle the scale that applications were starting to reach. So we had a problem where we just needed to figure out a way to access data quicker, scale it easier. And the solution there was just, hey, we need to move data from disk to memory. And this is what we call kind of the caching era. This is when the modern caching paradigm was introduced. And that was via the Memcached project, which Facebook really invested a lot in and popularized. We were during this era typically running on small on-prem servers. The cloud platforms were still not really ubiquitous or mature yet. Our applications were typically serving the same text and images to everyone. Applications were relatively simple. And users, user expectations were still pretty low as far as latency. Like users expected some latency. They're relatively patient. And Memcache was fantastic for this, right? You could really, it was simple commands, set and get, but it stored memory, it stored the data in memory and allowed applications to become much faster and to scale to much higher limits than had previously been possible. Fast forward to the introduction of Redis, and this is really what ushered in the stateless app era. And the goal with data infrastructure during this period was really, hey, we need to move the state from our app into the data layer, specifically the in-memory data layer. And this allowed us to open up a whole lot of different use cases with applications. We were now, as developers, starting to build these apps on the clouds. We were still using relatively small single dual core servers, and that's why Redis was built with its single threaded model, but we were able to start pushing things into the cloud and pushing some of the management burden there. And applications during this time were becoming more complex, more dynamic, utilizing more multimedia. And this was in large part thanks to the really rich APIs that Redis provided, right? It wasn't just sets and gets, it opened up all sorts of other application use cases. And during this time, users were also becoming a bit less patient. They were expecting lower latency. It had kind of become the norm, but for a really rich user experience, there's an expectation that there would be some additional latency involved. Fast forward to today, where the era we're in today, we call the real-time context era. And this is the era of machine learning, of AI, of use cases that really utilize much, orders of magnitude larger amounts of data and at much higher scale. So the data infrastructure goals today are, how do we scale out real-time access to terabyte sized workloads, right? That's kind of the new threshold of the amount of context these really high powered applications require. And the hardware we're running on today tends to be very large multi-core machines on the cloud, right? This is the norm today. And these applications are no longer static or even like somewhat dynamic. Any application involving machine learning or AI is delivering an extremely highly tailored experience that is customized for each user. And this is really key for this context era. It's that for every user, every use case, every query, there's a unique set of context that's required to deliver that highly tailored experience. And everything has to be real time. Like, users have very low, very low patience for latency and expect real time experiences whenever possible. And so, just to give a couple, like this real time context there, I know it's kind of a new concept. To kind of paint a clearer picture, I'm going to walk through a couple of specific customer situations where they were running kind of infrastructure from the stateless app era, running Redis, trying to scale these real-time context use cases and running into problems. So let's walk through that a little bit. So one example is Instacart, obviously a large grocery delivery service. And they had a use case where they were scaling a large machine learning feature store. And this was a large data set, right? 20 terabytes of data, over 100 million requests per second at peak volume. And the function that this feature store was serving was personalization, right? Making sure everyone's shopping experience was really personalized for them, that they were getting the products that they were most likely to buy recommended and surfaced to them, right? Which is very common for any sort of kind of e-commerce experience in 2025. So the challenge they had was that as they were scaling Redis and scaling up to and past 20 terabytes, they essentially hit a scaling ceiling because of the limits of the cluster sizes they could scale on Redis. And as their usage and customer base grew, their throughput was also growing, and they were starting to have performance suffer, particularly at the tail, and they're no longer able to hit the latency SLAs they had with their customers. They have specific latency requirements in their application. They were no longer able to hit that, and it was costing them money, right? This is their core business. And their existing solution, what they had started building on many years ago, was AWS Elastic Cache. And as they started hitting these scaling limits, they started kind of making trade-offs, right? They took different features and split them into separate clusters. They were introducing up to 4 read replicas per cluster to be able to handle the scale, which resulted in a lot of management overhead, right? So they essentially ended up in a position where when they started 5 years ago and the data set was quite small, Redis was a great solution. But as they scaled up, they were, having a very complex management overhead. They're having to make all sorts of architectural trade-offs to hit performance goals that were resulting in additional complexity and cost. And still, performance was not up to their requirements. Another example is ShareChat, which is not as much of a household name here in the US, but it's one of the largest social media companies in the world, based in India. And they're using Redis for all sorts of different personalization and high context use cases like recommendations, rankings, and more. And they had over 100 different Redis instances for different use cases, and had varying levels of kind of performance and management overhead as they scaled these different clusters. Some of their key challenges were that as their use cases and user base grew, costs were skyrocketing at a higher proportion even to their business. And the management overhead was growing in tandem with that, resulted in a lot of wasted engineering resources, and still the performance was not up to what their users expected. And so, yeah, they were running on Redis Cloud, had over 100 instances spread across a lot of different use cases, running on Google Cloud. Then again, this was another example of when they kind of started out and they were, had a small user base and simple use cases, Redis was fantastic. But as they started to pursue more of these kind of ML driven, machine learning driven use cases, and they went from, a couple 100,000 to a few million to tens of millions of weekly active users, the performance just suffered due to the fact that the infrastructure was never really meant to handle that type of scale. So this is kind of where Dragonfly comes in and what we built, why we built Dragonfly, because there has not been an in-memory data store that was built for these use cases in this era. So Dragonfly is able to deliver 25 times better performance than these legacy solutions while being 5 times more efficient, meaning less hardware required. It was really tailor built for massive in-memory data workloads. It is Redis compatible, so the same APIs that you would use with Redis, same client libraries work with Dragonfly. So it's a true drop-in replacement that is designed to run for large workloads on modern cloud hardware. When we say modern cloud hardware, we mean large VMs with lots of CPU power. That tends to be the norm today. We launched the project on GitHub in 2022, has over 29,000 stars on GitHub, very vibrant community, has been adopted by some of the largest enterprises in the world. And it is available on all 3 major clouds, right? Azure, AWS, and GCP. The cloud service, which we will demo later, it is the exact same database as the open source community version. It's just the management layer of automated kind of provisioning, scaling, backups, monitoring, et cetera, is the managed service. So why do what is the difference between the specific technical difference between Dragonfly and legacy solutions like Redis? Dragonfly is multi-threaded, right? And this is an architectural decision we made to be able to fully utilize all the CPU cores that are on these modern cloud machines. This allows us to deliver much better performance, much higher throughput per node. And it also enables much smaller cluster sizes. We typically see our customers be able to collapse their clusters coming from Redis to Dragonfly by 30, 40, 50%, which not only reduces costs, but also reduces management overhead dramatically. It's also highly optimized for memory efficiency. We rebuilt a lot of the data structures from the ground up, redid a lot of the compression, so that we can boost performance, reduce latency, and reduce the amount of hardware required. Often, if you take a data set, your Redis data set, migrated to Dragonfly, you're going to see an immediate 20% reduction in the amount of memory you actually need. And then lastly, simplifying operations, right? Like Dragonfly Cloud is fully managed, enterprise compliance, reduces all of kind of the DevOps burden. And it's also 100% compatible with Redis and Valkey and migrations. Even large enterprise migrations often happen in a matter of weeks, which we'll walk through some specific examples here next. So I spoke earlier about kind of the challenges Instacart was facing, right? They had this massive high velocity feature store. They were running it on Valkey with AWS Elasticache, had a lot of scaling issues. And they, after running a POC and evaluating a few different solutions, they decided to move to Dragonfly Cloud, still running on AWS. And they're able to reduce their cluster size by over 50%, able to dramatically reduce tail latency, 50% reduction in P99 latency, 30% reduction in infrastructure costs. They're able to complete this entire migration in weeks, right? And they had tried a lot of different things. They were on Redis Elasticache initially. They migrated to Valkey Elasticache to try to reduce cost, to try to boost performance. They had some marginal gains, but it was still not nearly enough for where they were at the time and where they're going, right? These use cases it's kind of just the tip of the iceberg. You're still experiencing explosive growth. So they have to think about the future as far as scaling goes as well. So they're able to get, dramatically better performance, dramatically lower amount of infrastructure, and the management overhead is significantly lower as well. The other example I mentioned earlier on ShareChat, again, they had over 100 Redis instances experiencing very poor performance. They also moved to Dragonfly Cloud running on Google Cloud Platform. and they were able to reduce their cost by 40%. And these are 7-figure spends, these are significant spends. So 40% is significant. And they're also able to migrate over 100 separate Redis clusters to Dragonfly in under 8 weeks. It was a pretty impressive effort on their end, but also speaks to the compatibility there. The code did not have to be changed. The libraries didn't have to be changed. It was mostly just a migration and kind of DevOps work that had to be done to change endpoints and things like that. And they had some specific performance issues around kind of noisy neighbors and multi-tenancy on Redis that they were able to eliminate on Dragonfly to further boost their performance there as well. So these are just a couple examples of companies that have been through that journey of kind of starting out with this legacy and memory data infrastructure that seemed like it was good at the time and was good for where they were at. But as these kind of very high data context use cases exploded, they quickly became bottlenecks that had to be solved. So that kind of wraps up the introduction presentation. Next, I'm going to hand it over to Joe, and we're going to walk through a demonstration of Dragonfly Cloud. So give me 1 second to swap that out of here. Here we go. So just before kind of Joe dives into the specific demo here, this is the console for Dragonfly Cloud. You can see there's a variety of data stores running here on different clouds through a single kind of pane of glass console here. You can provision infrastructure across any of the major clouds, any of the major, any regions on those clouds. And you have multiple connection options as well. You can connect via VPC peering with our kind of managed Dragonfly Cloud service that runs in our cloud accounts. We also have a bring your own cloud option where this can actually provision infrastructure in your own cloud account, which is a security requirement for a lot of organizations. Also allows organizations to take advantage of their own kind of cost commitments or spend commitments with the clouds. But yeah, Joe, why don't you go ahead and run us through this demo showing off the security master use case.
Sure. So yeah, hi everyone. Today we're going to show the security master demo in Dragonfly Cloud. So for security, we're talking about securities like stocks, not cybersecurity, just to be clear. And we'll be using this first data store over here. As you can see, it's 100 gigabytes enhanced compute. Yeah, we can easily access its Grafana dashboard here if you're interested as well. Maybe we can go just for a sec. Yeah, currently it has like over 55 gigs of memory used with our data set. So let's see them in action.
And real quick, Joe, before you hop into the data sets, I just want to call out this particular data store. It's 100 gigs with that enhanced compute. This is able to handle in excess of 500,000 requests a second, obviously up to 100 gigs of data. And this is a single instance. If you were to run this kind of you want to get the same performance and data capacity on a Redis or Valkey based instance, you would need to be running in cluster mode, likely with 4, 6, 8 nodes in the cluster, depending on the hardware you're running on. So you would already, like, even at this, like what's relatively small scale use case for Dragonfly can easily handle on a single instance. You would need to be, to get equivalent performance, you need to be running on a cluster mode with other solutions, which is obviously more complicated, also limits your commands and use cases. So just wanted to call it this is a single instance for this example.
Yeah, that's good. Thanks, Nick. So yeah, let's dive into the data set now. We have a new feature here, which is the COI within the console, which is very nice. We can try that today. So first, let's take a look at the data set we have right now. So we have about, it's taking some time, maybe because of my network. Let me try using the COI like from my terminal and see if it's a network issue or something. Okay, cool. So something wrong with the UI. Sorry about that. But as you can see, within the data store, we have around over 4 million JSON documents, and they represent different kinds of securities in the market. Right? So we can give it a peek over here as well. Let's try scan like the first 10 IDs, and let's take the first ID based on .get, and I'm going to run the this command with this particular ID. As you can see, we have a giant blob of numbers. Those are the embeddings. We're going to show off vector search later. But yeah, you can see this is a JSON representation of a particular security. It has the name, like the currency, what kind of stock is that, and the security name. So yeah, it's one of the example.
Yeah, and just to give a little more context for folks that aren't from kind of the financial fintech or financial services, these security master is essentially a master database that a lot of financial services companies use as their kind of source of truth for all of their financial securities. And these are used for reporting, data analysis, trading, any sort of like use cases where you need not only the securities, but like vast amounts of metadata associated with those securities. That's what the security master is.
Yeah, sounds good. Thank you, Nick. Now let me try to switch over to here because I have a different window that doesn't have the connection problem. So we have this many documents. We also have a search index, which is called index securities. And as you can see, we index a few fields. Some of them are vector fields, some of them are text, and some of them are tag fields. And the total number of docs in this index matches what we have earlier, because we essentially indexed everything that starts with the prefix of sec in their key name. Right? So we indexed the entire data set. So yeah, that's an overview of the data set. I think we're ready to do some search right now. Cool. First, let's try one with a particular ticker and exchange. Let me extend the query a little bit. So this is a search command. By the way, JSON and search are modules in Redis. So if you want to use them, you need to load the modules. And some cloud providers just don't allow you to load external modules onto that. But for Dragonfly, both the JSON commands and the search commands are built in. So if you use Dragonfly, they're there. They're always there for you. So this particular query, we're searching against the index we have before. And we are using two tag fields. So tag fields, it has a syntax like this. And for tag fields, we're looking for exact match. So in this particular case, we're looking for a security in the NASDAQ exchange with the ticker XYZ. And we're limiting the result to be just one, just so that it's easier to show the results. So let's run that. And as you can see, again here, this is our embedding. So this is like the embedding, the LLM model embedding of this security. And the ticker is indeed XYZ. And this particular security is from the NASDAQ exchange. So that's one example of doing a search against this index, and it's able to find the JSON documents that we're looking for. We're limiting to one, but we can have more if you need like the top 10 one from this whole data set. That's possible too. So that's one example. And we can try something else. We can try, let's say, a text match, right? Let me take the query over here. So similar as the previous one, we're looking for a tag match, which is an exact match. So the security must be of the technology sector, right? But for the name, we're not using the curly braces for the name. So we're looking for anything in their security name that contains Patel. So we're also limiting the result to one. Maybe we can try two in this case. And so we're asking for two results, right? Let's run that. And again, we have this embedding for the second security here, and then the embedding and the data for the first security. So they're indeed from the technology sector. And let's try find the name in here. It has to say Patel somewhere. Yeah, Patel, security name is Howard Patel, right? So yeah, this is a second example of doing a search against our data set.
And just a couple example like use cases that we see in the financial services industry for stuff like this is, you know, building a research portal or actually trading portal where you need to quickly retrieve security names and information is an obvious one, but also a lot of programmatic use cases as well, where you want to, you know, do some programmatic trading, quickly find securities with a specific attribute set. These are all kind of common real-time data context use cases in the financial services industry.
That's exactly. Um, yeah, just to add on that, for example, we can have this query where again we search the security name and last price. We index the last price as a number field, so it can do range queries as well. In this case, we're looking for security name containing that, and then last price must be higher than 200. We can try that too. So yeah, this result we're limiting to one result, and this should match what our query was asking for. Cool. I was trying to look for the last price in here, but it's a bit hard to read when the JSON response is like a little bit too big. Cool. So that's that. And finally, we'll try to do a similarity search. Right? So in order to do that, what would happen is that when we type a query, then the query needs to be transformed or embedded by a large language model or like a model. And then it generates back the vector. And then we use that vector to search against our index, right? So in order to do that, the text to vector part is a little bit hard to do directly over here in the console. So I have a tiny program that can help us do that. So let me switch to that just real quick. So yeah, here's my program. And if I type in anything over here, say, find securities that are related to Apple, what will happen is that this program will take this query and do a model embedding of this text and then search against our vector fields of our security as you saw before. So let's try that. Oops. So there's like the TCP connection timeout issue. Let's restart the program and give it a second. Okay, let's try the query again. And as you can see, it's like almost instant, right? And it gives us like the top 3 IDs of our securities. And now we can inspect those IDs too, see if they actually match what we're looking for over here, right? So switch back to the Dragonfly console, and I can do a JSON get with the ID. And yeah, let me scrolling up. And here is the security description. This is the field we embedded for our vector index. As you can see, it doesn't say exactly Apple in the description, but the magic of AI, of language models, is that we were able to see Macintosh in here, which means that it is a similar result, at least currently with a higher rank in our data set.
Mm-hmm. And obviously the use cases here are this is already happening and across a lot of like consumer facing applications. Hey, here's my portfolio, help give me other securities that will fit well into it, or hey, I want to have more exposure to this industry, give me recommendations that match what's existing in my portfolio. There's all sorts of kind of consumer facing AI use cases like this. There's also in the financial services industry, there's also tons that are more in proprietary trading, right? Hey, these have been our most profitable trades over the last 6 months. here's the reasons we believe they're profitable. Give us other, opportunities to make similar trades. And these use cases exist across any industry, these similar types of use cases. And the key here is that for these, these models, for these type of use cases that rely on these large language models, the more context you have, the better the model is going to be. So these use cases really, like Dragonfly really is built for these type of use cases where you have a lot of data, can have very high throughput potential depending on the way it's being utilized and the scale you're running at, how large your customer base is. These are use cases that are very challenging with legacy and memory data infrastructure, but that are very, very simple to achieve with Dragonfly.
Yeah, that's correct. Maybe we can try just the second one just to see that it's actually doing. I'm searching for something related to Griffin Healthcare, and let's also inspect the document again. And this time we have, again, these are embeddings. We have something that is in this case, our dataset happens to have the keywords Griffin and healthcare in the description. So it's, the precision is not it's depending on what the actual data is, right? So in this case, we happen to have these words in here, and it's a very high rank in the similarity search results. So we're able to find something like this too. Dragonfly is fully compatible with the Redis and Voki API. Normally, we use this kind of systems, including Dragonfly, with key value commands. But as you can see in this case, we're using the search commands and the JSON commands, which is part of Redis stack or Redis modules. We support them natively as well. So these are compatible commands. So that we try. Yeah. Cool. And I think that's it. That concludes the demo portion of the webinar. Cool.
Yeah, thanks for running through that, Joe. That was great. If anybody has questions, feel free to drop them in the chat. Otherwise, if you are interested in getting a more in-depth demo or running a POC in your environment, you can always reach out to us. We have a contact form on the website where we're happy to discuss your use case, see if it's a good fit for Dragonfly. Again, if it's high throughput, large data sets, lots of data context, that's going to be where Dragonfly is going to be able to deliver the most value. We also have, you can just sign up and use the product for free. We give $100 free credit if you want to just kind of get going on your own. So visit dragonflydb.io if you want to get started. Any questions in the chat? See, there's a question about getting the recording. Yes, we will be sharing the recording with everyone that registered. We'll be posting it in our YouTube channel as well. I don't think there are any other questions at the moment, but thank you all for joining, and I appreciate the time, and talk to you later. Bye.
Thank you. Bye.